My name is Jonathan Aguiar. C number is 23608790, and this is my lab 1. For the first gate, I will be doing the NOT gate. In the NOT gate, I use the NAND gate, which would invert the input for its output. For the next gate, I will be doing the AND gate. For the AND gate, I use a combination of one NAND gate and one NOT gate. The NAND gate would first invert the A and B inputs to get an output of the NAND output, and then that output would then go through a NOT gate to invert it once more for the final output. For the next gate, I will be doing the OR gate. In this gate, I use the combination of two NOT gates and one NAND gate. The input values A and B would first go through both NOT gates, inverting it into NOT A output and NOT B output, which then go through another gate, the NAND gate, to get our final output. The next gate will be the XOR gate. For this gate, I use the combination of one AND gate, two OR gates, and two NOT gates. First, the A and B input would go through the AND gate and then out to get an AND output. Then those same two inputs will then go through an OR gate to get an OR output. And then before those two outputs can be used, the OR output would first go through a NOT gate to get a NOT output value, and then the NOT output value and the AND output value before will then make an OR output. That OR output will finally go through one NOT gate to get the final output value. The next gate will be the MUX gate. For this gate, I use a combination of one NOT gate, two AND gates, and one OR gate. The NOT gate would first take the input value of the selected value and make it the not selected value for the output, which then goes in through one of the two AND gates for the not selected value and get an output of not selected value for A. And then the other AND gate would take the selected value and the input value B for an output of B and selected. And then finally, both outputs will go through the OR gate and get the final output. The next gate will be the DMUX gate. For this gate, I use a combination of one NOT gate and two AND gates. The NOT gate will first take the input of the selected value and then make it the not selected value, so then the next two AND gates can have an input of the not selected and an input of a selected. And then it would give us the final outputs of either A or B. The next gate will be the NOT16 gate. For the NOT16 gate, I use 16 different NOT gates to get different outputs for 16 different times. For the next gate, it will be the AND16 gate. Much like the NOT16 gate, I use 16 different AND gates for 16 different input values for A and B to get a different output value. The next gate will be the OR16 gate. The OR16 gate has 16 different OR gates with 16 varying input values for A and B. So each of them can get a different output or final output. The next gate will be the MUX16 gate. The MUX16 gate, like the previous one, has 16 different MUX gates which take different selected input values of A and B and get a different varying output value. However, the selected value will always stay the same. The next gate will be the OR 8-way gate. For this gate, I use 7 different OR gates. For the first part of this, I used 4 different OR gates, which took in 2 of the 8 selected input values for A and B and got 4 different outputs. Then 2 out of the 4 outputs would then go through another OR gate, which would give us another output 5 or 6. And then finally, those 2 outputs go through another OR gate to get our final output at the end. The next gate will be the MUX4 Way16 gate. In this gate, I used a combination of 3 MUX16 gates, which basically took the input values of 2 out of the 4 input values. However, the selected value would always stay the same. The next gate will be the MUX8 Way16 gate. For this gate, I used a combination of 2 MUX4 Way16 gates and 1 MUX16 gate at the end. The MUX4 Way16 gates each took in 4 different values for the inputs and 1 selected value in order to get an output. Those outputs from the MUX4 Way16 gates would then go through a MUX16 gate to get our final output. The next gate will be the DMUX4 Way gate. In this gate, I used a combination of 3 DMUX gates. For the first 2, we would get an input value, or the first one, we would get an input value and then a selected value. So we can get a different output for the A and the B. And then afterwards, the next 2 DMUX gates, we would take the output of A for one of the DMUX gates and an output of B for the next one. And afterwards, going through those 2 DMUX gates, we would get another 2 final outputs, which would be for A and B. The next gate will be the DMUX8 Way gate. For this gate, I used a combination of 1 DMUX gate and then 2 DMUX4 Way gates. The DMUX gate would first take an input value and the selected value, and then give us an output of 2 outputs of 4 different variables, A through H. Afterwards, the 4 out of the 8 variables given from A and B would then be inputted into one of the 2 DMUX4 Way gates. Afterwards, we would get a final output for both of those gates.